Hello everyone. In this video we are going to learn about decimals. In class 6, this video is for class 7 and in class 6 children you people have learned about decimals, addition and subtraction of decimals. Now we have to move forward in this video or in this class you can say. The number expressed in decimal forms are called decimals. The examples have been given in the book. 6.8, 16.73, 7.34, 364 or etc. Remember children, decimal is composed of two parts, that is whole number part and decimal part. And these two parts are separated by a dot called decimal point. Yes, and the part on the left side is called whole number part and the part on the right side is called decimal part, as it has been given in this example. In this example, this one 73.62 73 is the whole number part or integral part also you can say, and 62 is the decimal part. Now let's move forward. Yes, now decimal places. The number of digits contained in decimal part of a decimal gives the number of decimal places. Yes, for example, let's understand this by the given example 5.74. In 5.74, the decimal is 2 places. And in the second example 8.536, it has 3 decimal places. Now let's learn about like decimals. Decimals having same number of decimal places are called like decimals. For example, 6.73, 8.05, 19.68. You can notice there that on the right side, that is in the decimal part side, all the decimals contain 2 digits in decimal places. That is in a first example, that is in 6.73, there are 2 decimal places. In the second example, that is 8.05, there are 2 decimal places, that is 0 and 5. And in the third example there are 2 decimal places, that is 6, 8. So these are called the like decimals. So if two decimals have same number of decimal places, then they are called like decimals. Let's move to unlike decimals, just opposite of it. If the decimals have different number of decimal places, then they are called unlike decimals, like 5.63, 8.64 and 10.023. These all have 1, 2 and 3 decimal places respectively. The first one, that is 5.3, has 1 decimal place, that is 3. The second example, that is 8.64, has 2 decimal places, that is 64, and the third one has 3 decimal places, that is 0, 2 and 3. Yes, now let's see the important result. Putting any number of zeros to the extreme right of a decimal part of a decimal does not change its value. Let's understand it by example. See the example 3.8. This example 3.8. If we put 1 0 or 2 0 or any number of zeros on the rightmost part of the decimal, then it does not change its value. You can put here on the right of the given decimal infinite number of zeros and they will not change its value. That is 2.94 is equal to 2.940 or 2.94 is also equal to 2.9400. You can put a number of zeros but the value of the decimal will be same. Let's see the place value chart of decimals. Yes, earlier we have seen the decimal place value chart of Indian place value chart and international place value chart we have been familiar with. Now we have to see the decimal place value chart. In this, the integral part or the whole number part is same as before, but the decimal part will change a bit. In decimal part, we start from leftmost part of the decimal part. Like the given example is 374.568. In this decimal, 374 is the whole number part or the integral part, and 568 is the decimal part. And now we have already been familiar with the 374. You all know how to arrange 374 in the place value chart. But let's learn about the place value chart of decimal parts. It starts with leftmost part, that is, if it is 568, then we will start from the 5, that is 5 is the leftmost part, 5, then 6, and then 8, and it moves in this way: tens, hundreds, thousands, 10,000, and so on. You have to write THS at the end of all places, that is tens. Earlier you used to, in integral part you will write tens, 10 and 1 s, but in that decimal part you just have to remove s and write THS in all the places. Like if you write hundreds in integral part or whole number part, you will write hundreds, that is THS. 100 is as usual, just you have to write THS with it. Okay, and the leftmost part, that is 5, is the tenths place. The second leftmost part is the hundreds place, that is 6 is the hundreds place, 8 is the thousands place. Now let's move through the next page. Yeah, in this section we are going to compare two or more decimal numbers, or decimals also you can tell them. Let's start. Let's see this example. You have to arrange it in ascending order. Ascending order, you have already arranged the numbers in ascending order in the previous chapters or previous classes also. But this time it is decimal number or decimals, so you have to be a bit careful. To compare or to arrange in ascending or descending order anything, you have to see the integral or whole number part of any decimal number. Like in the example number 2, we have 5.74, 6.03, 0.8, 0.658 and 7.2. We have to see the integral part or whole number part of all these numbers and first arrange them. You can see that the greatest number out of all these given decimals is 7.2. You can just first I've already told you that you have to compare the integral part first. So 7, if we see the integral part or whole number part of all these decimals, that is 5.74, 6.03, 0.8, 0.658 and 7.2, we come to know that 7 is the greatest integral or whole number part out of all these numbers. So this is the greatest number. We have to arrange it in ascending order. It means lower to greater. We have to write the least number first and then the greater, then greater, then greater, and at last greatest. So in this example, in the book it has been written to convert the given numbers or decimal numbers or decimals, you can say, into like decimals, and then you arrange it in ascending order. But you can do away with it. It means you can ignore it. You can ignore the step of converting the decimals into like decimals. You can just write it directly. See, the smallest whole number part of these all numbers is 0. This one, this 8, 0.8 and 0.658. And out of these two, these two contain 0 in their integral part. So how will compare now? Now we move to the leftmost part of the decimals, that is a decimal part, that is in out of these two numbers, that is 0.8 and 0.658, we see the leftmost part, that is the point 0.8 in the first one and zero point 0.6 in the second one. And you must be knowing that out of 6 and 8, 6 is lower number. So out of all these numbers that we have to arrange in ascending order, 0.658 is the lowest or smallest number, decimal number, or decimal you can say for your convenience. So 0.658 is the smallest. Second smallest number, we can clearly notice it that it is 0.8. Now next means third smallest decimal out of these all, we can now compare. We are left with, first of all, see, we are left with 5.74, 6.03 and 7.2. And out of all these numbers, that is 5.74, 6.03 and 7.2, the 5.74 is the smallest, because we can compare the whole number part first, and the whole in while comparing the whole number part, we come to know that 5 is the smallest of all three. So 5 is 5.73 is 74, sorry, is the third smallest number or decimal number you can say. And then comes the 6.03, and at last comes the 7.2. Now it has been arranged in the answer. Sorry. So try it yourself.